All right, so I told you guys before that all of the trig functions, sine, cosine, and tangent, that we deal with were not really all of them. There were three additional trig functions. Those trig functions were secant, cosecant, and cotangent. Well, those are actually three trig functions which are relatively easy to deal with if we understand the first three, sine, cosine, and tangent, because as you will see here, cosine is the reciprocal, which just means, if you guys don't remember reciprocal, reciprocal is something where the fraction is flipped over. It's the reciprocal of the trig function secant. They are reciprocals. Sine is the reciprocal of the one which is called cosecant. And then tangent is the reciprocal of cotangent. And really, that's the only one that tends to make sense as far as the words are concerned. All right, so what does that mean? Well, um, cosine is the reciprocal of secant. So what that means is, if I want to find the secant of a certain angle, and I know the cosine of that angle, I can simply take the cosine value and flip it over, and that's the secant value. We should probably write up here that the abbreviations, because all of these have abbreviations, like sine is sin, tangent is tan, cosine is cos. Secant also has an abbreviation, which is just the first three letters, sec. Cotangent, it's cot. And we can't use cos for cosecant because it's already being used by cosine, so instead we abbreviate it csc. Okay, so if I want to find the secant of pi fourths, well, I need to know the cosine of pi fourths because they are reciprocals of each other. So if I know the cosine of pi fourths, and the cosine of pi fourths is the square root of 2 over 2, that makes the secant, the reciprocal, flipping it over, 2 over the square root of 2. And yes, that is okay to leave like that. However, I'm going to go ahead and rationalize it just to show you that when you rationalize this one, it does simplify quite easily. To rationalize, we're going to multiply the top and the bottom by the square root of 2, which will give us 2 square roots of 2 over square root of 2 times square root of 2, which is just 2. And hopefully what you can see there is the 2's divide out, which leaves the square root of 2. So the secant of pi fourths is the square root of 2, which again, if you already know the cosine, you just take the cosine and you flip it over, and that gives you the secant. Same idea over here with cosecant. Cosecant of 2 pi thirds, well, that's the reciprocal, according to this, of sine. So if I know the sine of 2 pi thirds, and the sine of 2 pi thirds, again, all this stuff is coming from the circle, sine of 2 pi thirds is the square root of 3 over 2. Well, if I take that value and I flip over the square root of 3 over 2, we're going to get 2 over the square root of 3. That is the cosecant of 2 pi thirds. And again, it is fine to leave like that. We are going to rationalize it, but you could have left it as 2 over the square root of 3. That is actually acceptable. This one becomes 2 times the square root of 3 over square root of 3 times square root of 3 is just 3. That one does not simplify any further than that. But that's the cosecant of 2 pi thirds. And 2 pi thirds is in the second quadrant. Sign is positive. Therefore, when you flip something over, you're not changing the signs. You're not making anything different, positive or negatives. We're not taking an opposite reciprocal. We're just flipping it over. So whatever the sign of sine is, cosecant will be the same thing. And then tangent. There's two different ways to think about tangent. Tangent is the reciprocal of cotangent. Cotangent is the reciprocal of tangent. It works both ways. If I want to know the cotangent of 5 pi sixths, remember, in order to find the tangent of something, we did the y over the x, or we did the sine over the cosine. But if cotangent is the reciprocal of tangent, couldn't I just write the cotangent as x over y instead of y over x, which would actually be the cosine over the sine? So I could do it that way. So you can find the tangent first and then flip it over, or you can avoid the whole flipping thing and just go straight to x over y or cosine over sine. So I'm going to do it the second way. I'm going to do it the way I did in red here. So the cotangent of 5 pi 6 would be the same thing as the cosine of 5 pi 6 over the sine of 5 pi 6. Okay, cosine of 5 pi 6. Anything that has a 6 in the denominator, the cosine of that is going to be a square root of 3 over 2. And 5 pi 6 is in the second quadrant, which makes the x value or the cosine value negative. And if the cosine of something that has a denominator of 6 is square root of 3 over 2, then the sine of that has to be a 1/2. And again, that's second quadrant, so the y value in the second quadrant is positive. And then if you guys remember, anytime you divide these two things with the same denominators, the denominators are going to go away, because when you bring the bottom up, flip it over, and multiply, the denominators will cancel out, leaving us with just a negative square root of 3 over 1, which is the negative square root of 3. And there's your cotangent of 5 pi 6. All right, so it says you try it. Go ahead and take a few seconds to go ahead and get that started. I am going to put the answers up here, so at this point, if you want to pause the video and try and work on it on your own, by all means go ahead and do so. I'm going to go ahead and write these answers up there for you guys. So the cosecant of pi 6th. Cosecant is the reciprocal of sine. Sine of pi 6 is 1/2. Flipping over 1/2 is going to give us 2. Okay, the next one. Cotangent of 3 pi 4ths. Well, this one I'm actually going to think of in terms of tangent. If tangent of 3 pi 4ths, it's sine over cosine. Sine and cosine at all the pi 4ths are both square root of 2 over 2. So anytime I divide the same thing by itself, I'm going to get 1. The only difference is this is in the second quadrant, so the x is negative and the y is positive, which makes the whole thing a negative value. So this will be negative 1. Secant of 7 pi 4ths, that's the reciprocal of cosine. So cosine of 7 pi 4ths is the square root of 2 over 2. The reciprocal of that would be 2 over the square root of 2. And 7 pi 4ths is the fourth quadrant. Cosine is the x value, so x is positive in the fourth quadrant. And again, that one we've done up there above simplifies after you rationalize it to just the square root of 2. And it's actually okay to leave it in either case, either way, but you'll more commonly see it as the square root of 2. Cosecant of 5 pi 4ths. Same idea. This is a pi 4ths. It has a 4 in the denominator. Cosecant is the reciprocal of sine. Sine is going to be a square root of 2 over 2. So flipping that over, we get a 2 over the square root of 2. But 5 pi 4ths is the third quadrant. And since this is sine and y is negative in the third quadrant, that's negative. And then again, rationalizing that would give you a square root of 2, but since it doesn't change the sign, it's the negative square root of 2. Cotangent of negative 270. Now you have to think about this one for a second. Negative 270 degrees, that's going backwards around the circle. So if I start here, negative 270 starts here and goes to there. So it's really going to end up in the same location as 90 degrees, which is pi over 2. And we're talking about cotangent. Cotangent, remember, is not going to be y over x, it's going to be x over y. So the point here is the point 0, 1. Well, if I want x over y, that's going to be 0 over 1, which is just 0. And then secant of 11 pi sixth. Okay, again, secant is the reciprocal of cosine. So I have to know the cosine at all of the pi sixths. The cosine at every pi sixth is a square root of 3 over 2. So if I flip that over, that's going to be 2 over the square root of 3. And 11 pi over 6 is in the fourth quadrant. Cosine is the x value, so x is positive. So that's the answer, 2 over the square root of 3. And again, if you rationalize, that becomes 2 square root of 3 over 3. Not necessary, but more commonly probably seen 2 square root of 3 over 3 as opposed to the unrationalized version. Both are correct. Okay, second page. So this time we're giving you a point, and you have to determine the angle. So the first thing is the point is the point -1/2 square root of 3 over 2. It's asking us, is that a point that's actually on the unit circle? Is that a standard position? Yes, it is. That is on the unit circle. Okay, that one you should recognize. Now the question is, what's the angle? Well, we're going to do the angle in both degrees and in radians. So theta, well, let's see. That's -1/2 square root of 3 over 2. So x is negative, y is positive. That's got to be in quadrant 2. So we know our angle has to be in quadrant 2. And I know that the cosine has to give me 1/2. Cosine is going to give me 1/2 at the pi thirds. So the one that's in quadrant 2, which has a 3 in the denominator, is 2 pi thirds. And 2 pi thirds, in terms of degrees, well, that's a 60-degree angle, but that's 2 of them, so that's going to be 120 degrees. Now that I know that, the rest of this isn't going to be hard. The cosine. Cosine goes with x. The x value is -1/2. That's given to us in the point. The sine goes with the y value. That's square root of 3 over 2. And then tangent is the y over the x, or the sine over the cosine, which would be a square root of 3 over 2 over -1/2. But if you put those on top of each other, the denominators, the 2's are going to go away. So all I end up with is a square root of 3 over -1, which is the same as the negative square root of 3. Once you have these three, the other three are easy. Cosine goes with secant, flip it over. Sine goes with cosecant, flip it over. And I'm not going to rationalize these, I'm just going to leave them. Cotangent goes with tangent, flip it over. Well, how can you flip over a whole number? Just remember that negative square root of 3 is like negative square root of 3 over 1, right? I'm going to go ahead and get rid of that over 1 part because we don't usually write that. But if you flip over square root of 3 over 1, you get 1 over the square root of 3, and don't forget that it's negative. So there you go. Now, a little trick to know all of the trig functions and their reciprocals. What you should notice is that every trig function that has the letters CO in the beginning are the co-functions. For example, cosine, cosecant, cotangent has a reciprocal, which is a non-co-function. Cosine goes with secant. Cosecant goes with sine. Cotangent goes with tangent. So all co-functions have a non-co-function as their reciprocal. The tangent and the cotangent one just kind of makes sense because the words seem to go together. The other two you do have to just make sure you keep straight. But remember that every cofunction has a non-cofunction as its reciprocal function. That might be an easy way for you guys to remember which ones are which. Get rid of those little check marks there. Okay, suppose we have a point now that doesn't actually lie on the unit circle. So the point 3, 4, it's just an ordered pair. It's the big dot that you see here on the right. It's going to be the point that's going to create an angle with the positive x-axis. As you can see here, this does create an angle going out to that point. But 3, 4, as you can tell by looking at that point, that is not something that's on our unit circle. It's not one of our standard unit circle points. So we've got to come up with another way to do this. Well, the idea is this. What you should see is, by what I have drawn here, I have basically two sides of a right triangle. If I drop an altitude from that point straight down to the x-axis, I have now created a right triangle. I specifically know that the angle, the green angle right there, is the angle in question. What I should know by looking at the distances is that altitude that I just dropped had a distance of 4 units. Well, isn't that just the opposite side of the triangle? The horizontal distance from the origin out to where I just dropped that altitude is a distance of 3, and that's that. Well, anytime you know two sides of a right triangle, you can find the third side by using the Pythagorean theorem. So, Pythagorean theorem was a squared plus b squared equals c squared, where c is the hypotenuse. Well, the hypotenuse is the length from the origin out to my point. The two legs, a and b, are 3 and 4. So what I've got is 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16. Adding those together, we get that 25 equals c squared, or c, taking the square root on both sides, would be 5. Now I have all three sides of the right triangle. I can use my old SOHCAHTOA to go ahead and figure out all the values of that angle. I don't even need to know what the angle is. I can figure out all the values of the trig functions because I know the three sides of the triangle. So, cosine. Cosine was adjacent over hypotenuse. The adjacent side here is 3. The hypotenuse is 5. So cosine is 3/5. Sine is opposite over adjacent. Opposite is 4. Hypotenuse is 5. So sine is 4/5. And then tangent is opposite over adjacent. So that would be 4 over 3. And then again, once you know those three, as long as you know what reciprocal functions go with which, all you have to do is take those values and flip them over. Cosine goes with secant, so that's 5/3. Sine goes with cosecant, so that's 5/4. And cotangent goes with tangent, so that's 3/4. All right, that is how to find the 6 trig functions if the point is in the first quadrant. So none of those values were negative because everything was in the first quadrant. We can do that now for any point in space because we can always create a right triangle given the fact that we can create a hypotenuse from the origin to that point. So now we have to sketch them ourselves. Suppose that we have the point 8, -6, and that falls on the terminal side of an angle. So the idea is pretty basic, and it doesn't have to be a perfect sketch. But find the point 8, -6. Well, that's in the fourth quadrant. X is positive, Y is negative. So we're going to go out 8 units, down 6 units, somewhere maybe approximately right there. It does not have to be perfect. You just have to have the general idea. But I did go 8 units out this way, and then I went 6 units down this way. So really what I've got from that point to the origin is the hypotenuse. So this was 8, this was -6. Once again, if you use the Pythagorean theorem, (8 squared is 64, -6 squared is 36, adding those together you get 100, so that makes C 10. And here is the angle that we made right in there. So now we can use that information to be able to figure out our 6 trig functions. And the negatives are already in the correct place, so just make sure you keep that straight. The only thing it does say we want to do is put this in simplest reduced form or simplest radical form. There actually won't be any radicals in this one because they're all whole numbers. So let's do the cosine. Cosine is adjacent over hypotenuse. Adjacent is 8, hypotenuse is 10. So our cosine will be 8/10, which reduces to 4/5. Sine is opposite over adjacent, so that's, opposite over hypotenuse, so that's -6 over 10, which reduces to -3/5. And then tangent is opposite over adjacent, which is going to be -6 over 8, which reduces to -3/4. Reciprocals are easy. Flip over cosine for secant, we get 5 over 4. Flip over sine for cosecant, we get -5 over 3. And then flip over cotangent flip over tangent for cotangent, we get -4 over 3. Okay, not really very difficult to do. You just have to be able to find where that point is, sketch the appropriate angle, use the Pythagorean theorem to figure out the rest of it, and then fill in the 6 trig functions. So your homework is actually here on page 4. There's a couple of corrections I'm going to make on this homework for you guys. One, it says you're supposed to find all 6 of the trig functions that go with the specific point given. As you can see, there's only 4 listed for each one, so we're going to go ahead and add in the other 2. The first one has sine, cosine, tangent, cotangent, so we need to add in secant and cosecant, and you're going to find those 6. Number 2 has sine, cosine, cosecant, cotangent, so we're missing secant and tangent. So we need to add those in. Number 3, that's fine. That one looks okay. And number 4 we need to make a correction on because it says given cosine, and then at the end it says find cosine. Well, we already have it, so we're going to change that. I want you to find sine instead of cosine because I already gave you cosine. So really what I want you to find is tangent and sine. Now, what you're going to run into here on number 4 is you're going to run into something when you do the Pythagorean theorem that is not a perfect square. So when you try to take the square root, a lot of you guys are going to want to try and take this and use decimals. Do not use decimals. If the square root does not work out, say you get something which is the square root of 15. That is not a perfect square, so you just leave it as the square root of 15, and it's okay to have that. Just like if we had the square root of 3 or the square root of 2 that we can use on the unit circles, we leave them that way. So if it does not work out to be a perfect square, and it won't on number 4, leave it under a square root when you go to do your 6 trig functions, or your 2 trig functions that you have there. One last thing I'm going to cover with you guys, because I want to make sure you guys understand. I'm going to go back to page 3 here. I want to make sure you guys understand one thing real quick here. These are what are called the reciprocal properties that we've been talking about. And I didn't write it on the first page, but when I say reciprocal, when I say that the other one it's something flipped over, sine, because it is the reciprocal of cosecant, is 1 over the cosecant. Or, likewise, cosecant would be 1 over sine. Okay, that's the way the reciprocal properties work. One is the other one flipped over. So, likewise, cosine is the reciprocal of secant, and secant is the reciprocal of cosine. And then the last one, tangent, is the reciprocal of cotangent, and cotangent is the reciprocal of tangent. So that's really what are called the reciprocal properties. For trig functions. All right, that should be enough. You guys should have enough to do your homework. I will post the answers to at least one half of the homework and how we work that out. And from the other day, for those of you guys who didn't get a good explanation on some of that stuff. The other half I don't have, but that was just filling out the first quarter of the unit circle and finding those special values. So you should be pretty good with that. All right.